Hey everyone, it's Dr. Walker. This is video 41C, Gravitational Potential Energy. We just finished talking about work and kinetic energy. Kinetic energy was energy associated due to an object's motion. And then we saw the work kinetic energy theorem, which showed that the external work done on an object, all of that work done on an object was changing its kinetic energy. In this video, we want to talk about a different kind of energy called gravitational potential energy. So let's take a look so that we can understand it a little bit better. Let's first consider the work done to lift an object at a constant speed. So we're lifting an object such as our beloved physics book with an applied force. And we're just applying enough force to balance the weight of the object. So the object is in equilibrium and the applied force is equal to the weight. The magnitude of the forces are equal to each other. They're just in opposite directions. We're just doing this so that we don't have any extra acceleration in the y direction. So let's find the work done to lift the object. It's a constant force. So the work done by this applied force here, we'll kind of I'll just call it WAPP for the applied, is going to be the applied force, the dot product of that and delta R. So the applied force has a magnitude of mg, but it is upward in the j direction. And then delta R is going to be y final minus y initial. We are lifting the book from this initial position to this final position. That's our delta R right here. And that is also in the j direction. When we take the dot product, we know that j dot j is equal to 1. So we are essentially distributing the mg. We get mg y final minus mg y initial. So this is the work done by an applied force in lifting an object slowly against gravity. We'll come back to this in just a minute. Now, let's look at the work done by gravity on an object as it falls. When an object is falling, we know that the weight is acting on it. And we know that it's falling downward. The delta y is downward. So we know from our definition of force times distance that we have positive work done by gravity. Let's calculate that positive work. The work done by gravity, call it W sub g, is equal to the force, which is the weight, dot product of the weight and delta R. So the weight is straight down, so we're going to say negative mg in the j direction, and delta R is still the final position minus the initial position. The book is going from here down to here. Delta y is going to be negative. So y final minus y initial, j direction. We're going to take the dot product here. We're going to distribute. We're going to have negative mg y final plus mg y initial. And we can rewrite this as mg y initial minus mg y final. So now we're ready to talk about what this mgy really means. So mgy, we're going to define it as the gravitational potential energy of our object. Now it has to be relative to something else, right? The reason that our object has this gravitational potential energy is because it has a certain height relative to the Earth. So whenever we talk about gravitational potential energy, it's always the energy of a system. In this case, the system is the box and the Earth. And because they have a certain configuration with respect to each other, they're a certain distance apart, certain orientation, then that gives them potential energy. And we're usually just looking at the potential energy of the object. As we can see from this expression, the potential energy depends on height. Sometimes some books will call it mgh. So the more height that you have, the more potential energy that you have. Because it's energy, it's in joules, and it is a scalar. So what's really important about the gravitational potential energy is that it always has to be measured relative to something else. Usually that something else is going to be the surface of the Earth here, which we would call the y initial equals 0 meters. We'd say that that's our zero position, and then whatever height our object has, that is going to be relative to the zero. Now, it's not always the case that the ground is going to be the zero level. We'll do some examples where we can arbitrarily set our ground level to be at any location that we want. But the important thing for now is that the potential energy is measured relative to something else. Now let's go back and look at the previous couple slides for just a minute. So when we lifted the object, we saw that the work that we did here was the change in potential energy of the object, right? The final minus the initial. So this means that as we lifted the object upward, we gave it gravitational potential energy that it's storing. And it wants to release it and convert it to kinetic energy. We'll see that soon. But we're just saying that we did some work and we changed the potential energy. Just like in the previous few videos where we did some work and we changed the kinetic energy. In this case, we did not change the kinetic energy, we just changed the gravitational potential energy by giving the object height. And also, if we look at the work done by gravity, because it's the initial minus the final potential energy, we can call it negative delta UG. And what this is saying is that the work done by gravity is not increasing the potential energy, but it's actually decreasing the potential energy. And we can make a note of that, right? Work done by gravity reduces the gravitational potential energy. And we'll actually see that later too when we talk about conservative forces. The object naturally wants to fall because of gravity. Its gravitational potential energy will decrease because it will get down to zero height. But as it does so, it will gain kinetic energy. Let's look at a couple of questions. This first one here. Rank in order from largest to smallest the gravitational potential energies of the balls. So pause the video and think about it. We can see that we have a ball going upward. It seems the green arrow is the velocity, so it has a high velocity, while we have balls going up and down, and then a ball at rest. So if we're looking for gravitational potential energy, that's going to be UG equals mgy. So remember, it only depends on the height. So all this information about the speed really doesn't matter. Relative to this ground level, if we call this the ground level, then ball number 3 is going to have the most energy because it has more height. And then 2 and 4 will have the same energy because they have the same height. And then 1 will have the least energy because it's at zero level. It actually has no energy relative to the surface. So that is our answer for this one. Let's look at one more. A woman pulls up a crate up a rough inclined plane at a constant speed. Which statement is not true? So the best thing to do here is to just look at each statement one by one and see if it's true or not. So let's go ahead and do that. The gravitational potential energy of the crate increases as she pulls the crate up. So if we visualize this, we have a crate being pulled up here. That means that it is gaining height, right? It's going from some lower height here to some higher height. There's a y initial, there's a y final. So this is a true statement. It is increasing. The work done by the net force on the crate is 0. All right, so this is kind of a review of the work kinetic energy theorem. We know that the work done by the net force, is a change in kinetic energy. If we're moving at a constant speed, that means we don't have a change in speed, we don't have a change in kinetic energy. So the net work is 0. That is a true statement. The work done on the crate by the normal force of the plane is 0. Well, the normal force is always perpendicular to the surface. So we know that that's true as well, because if the displacement is along the incline, then the normal force is perpendicular to the displacement, and that is zero work. That's a true statement. So the statement that is not true is that the work done on the crate by gravity is zero. That is not true. We know that the work done on the crate by gravity is equal to the negative change in potential energy. And there is a change in potential energy because there is a change in height, so there is work done by gravity. Now you should take a second to think. Is the work done on the crate by gravity, is it positive or negative? Put your answer in the comments below.